Welcome, everyone, to our next episode. It's a panel discussion. Hands up if you're running AI in your data center. Is immersion key to cooling dense workloads? So let's get going, and I'll be introducing our panelists as we get past these housekeeping notes. Right up front to everybody, good morning or indeed good afternoon. My name is Stephen Warren. I'll be the moderator for this panel, plus into our roundtable right afterwards. But I want to say to everyone, thank you so much for joining us. And depending on where you are, welcome to DCD New York, the global broadcast series for the enterprise data center ecosystem. Amazing that just 9 months ago, we hosted our second broadcast tracking the huge evolution of enterprise digital infrastructure amidst the pandemic. And here we are as the global vaccine rollout gathers pace and organizations pivot from analog to digital. There are new challenges and opportunities ahead for the industry at large. Over these 3 days, today is the second, tomorrow will be our third, we'll hone in on the strategy, design, and technology keeping the lights on in the virtual world and ask what kind of infrastructure will be needed to support future enterprise IT workload. And this panel is perfect for that. And of course, this is part of DCD's always-on content program for the data center, cloud, and edge infrastructure industry. We've pulled together a powerful lineup of industry experts to share their insight on this topic. I'd like to thank all of them for their contribution. And here's a glimpse of our upcoming broadcast schedule, where we'll be looking in depth at power and cooling, as well as regional data center markets, including more from across North America, Asia Pacific, Africa, and of course, Europe. Full details of our 2021 calendar are available at datacenterdynamics.com, where you can register now. And right at the bottom, you can see DCD Global Awards. Submit your entries now. That's right. Entries for the DCD Global Awards are now open, with new and updated categories, plenty of which are relevant to the enterprise data center. Do take a look at the categories in the awards website link in the resource box on your screen and start planning your entry today. And best of all, everything is recorded. We've got a global audience, so you don't have to miss a thing. You can watch all of our broadcasts whenever and wherever you like. Just look for the on-demand tab on our website top navigation bar. And of course, before we get started, just a few more items that you need to know. And that is, right across the bottom, you're going to see that functionality that you see on the left-hand side in red. But for you in the live screen, it's in green. We have a Q&A widget on the screen in front of you that you can use live. The moderators, myself, and others will try and include your questions in the speaker Q&A section. And if they don't give time to cover it now, we'll cover it later. And remember what I said, there's a roundtable on this topic coming up right afterwards. Also, you can see the resources widget. You'll find useful downloads and links relevant to this session. In fact, there's 2 great links just from Microsoft and Hussam alone. They're just wonderful to look at. You can also find the full live stream schedule here too. And on the screen, you'll find a link through to DCD Connect platform where you can network with speakers, delegates, and our sponsors. It's got some great functionality, so do check it out when you have the time. You can also find a link to our DCD Pulse survey on the console. Your input will help to inform the industry about enterprise data center trends. Please take the 5 minutes to fill it out. That's all it takes. And you can win $250 of Amazon vouchers as a thank you. Last but not least, many of our sessions have roundtables, I've said before, that follow on from the discussion. These are a great chance to talk with the speakers and your fellow attendees in a much more relaxed environment and share your views. And that's important, share your views. Like I said, we've got one coming up right afterwards. So without further ado, let's get started right on this. And that is, hands up if you're running AI in your data center, is immersion key to cooling dense workloads? We've got 3 wonderful people on the panel today. Daniel Pope from Submer. He's the co-founder and CEO, and we want to thank him so much and everybody at Submer for sponsoring this discussion. And also, Hussam Alisa, who's the principal engineer, data center advanced equipment at Microsoft. Many of us in the industry know him. And I gotta say, David Martinez, you have been in this industry forever. Everyone knows you and respects you for everything that you've done. He's the engineering program project lead at Sandia National Laboratories. So gentlemen, thank you for joining, but let's get started right away. If we could, I'm going to turn it over to you, Daniel, right up front. How are rack densities and power demands evolving? And I know you're going to ask me to move forward 1 slide, Daniel, so over to you.
Thank you very much, Steve. Yeah, I think this latest white paper from the ASHRAE, named Emergence and Expansion of Liquid Cooling in Mainstream data centers explains it pretty in a very resumed document, just 27 pages of super valuable and super interesting information, which really comes to resume the why we're here, why Submer is here, and why we started on this journey back in 2015. This single picture, I think, resumes that whole paper. The challenge of TDP and increasing chip densities, and how trying to cool these new chip densities with air is just not going to make sense, not only from a physics perspective, but actually mostly from a TCO perspective, because of the amount of energy that we need to inject to cool the future chips that are being released, or even current chips. So right now, we're mostly deploying, I guess, 200-watt chips, some 250-watt chips on the CPU side of things, on the GPU a little bit more. And that's already posing a challenge, and that's where we see Liquid aggressively coming into the data center space. And this is not something which is going to stop in any way. It's actually, this challenge is only going to continue. Silicon manufacturer roadmaps in the next couple of years announce chips in the range of 300, 400, and even 500 watts, where air cooling is just going to be completely out of the question. So rack densities are increasing, chip densities will continue to increase, and we need technologies that will allow us to facilitate the continuity of Moore's law, sorry.
No, totally understand, and thank you. You know, Hussam, you see this every day. You're dealing with it every day. If you could talk a little bit about this, especially your position at Microsoft, how this is something that, as you're working with it, you understand that the evidence suggesting that the application of AI here and ML is really critical, but we've got to understand air's just not enough, is it?
Yes, that's a great point. I mean, basically, the chip industry in general is facing the end of scaling laws, whether it's, as Daniel mentioned, the Moore's scaling law of transistor density, or Denard's scaling law, which affects the leakage power on the chips. Both of them are reaching to an end, and we basically are ending up with higher power chips that are difficult to air cool. The other element that's also contributing to the increase in chip power is we have a continuous demand. Customers require higher performance. We need better core monetization. And all these have been leading to the AI and the compute chips having increased features. For example, if we talk about higher physical core count, higher and faster frequencies, having high bandwidth memory on the chip, tight packaging for low latency, all these factors have led us to higher chip power, and more importantly, higher chip fluxes, watts per unit area. To the extent that chips can be, or difficult to be cooled in air, with air, and advanced cooling solutions such as cold plate or immersion become needed. So that's kind of from a chip perspective and what customer experience might need. And then if we move to the rack density, of course, higher density racks affect the footprint, and also affect the application and network latency when we hook up racks together and try to build a big AI supercomputer. So immersion and liquid cooling in general serves or solves that density and that chip challenge when we are reaching limitations of what air can do.
I've got to ask you, Hussam, you see this every day at Microsoft. Is it something that you're also dealing with, but sometimes gets you a bit frustrated because so many of your colleagues out there just don't understand this very simple chart says it all?
Yeah, I mean, we understand that switching from technologies could be a heavy toll. We also need to be cognizant that air cooling is not going away too. I mean, we would still have lower density or lower chip power applications, but I think it's on us to also help and push the industry and provide, work through guidelines and specs and share data to just show that we need to go through that route of higher density and higher power chip needs liquid cooling.
Perfect. David, I almost think that you need to write a history book on this, because you've seen this from the beginning when we were at low levels of density. What are you thinking about this one when you see it?
Yeah. So yeah, you're right. I'm like Father Time in a sense when it comes to liquid cooling, because I actually worked in the computer center when we cooled off the old Cray systems with the 4-night systems. So basically, we're not moving away from what we used to do. We've actually, it's like the evolution of power and cooling. I wrote an article a long time ago, how we're going to become a full circle to where we were. Basically, we had the right idea many years ago, and we moved away using air as time changed, but the densities still were growing. But we were smart in the way we were doing it and building the densities not as compact. But now when you're building, and I think the chips actually will go near 1 kilowatt per chip. We'll see that within a year, maybe 2 years or less. And the graphic interface cards especially, there is no way that you cannot get away from liquid cooling. But what we need to do is teach the community it's safe, and we're able to do this safely. And it's safe and it's very efficient. And with the energy, with the administration, the current administration here in the United States, that's all about saving energy. This is right down the pipe with that. Basically, getting the heat away directly. There's no other way to go. And you also have heat with the memory as well, because if you're doing a lot of high computing and overclocking, et cetera, then you're also going to drive your other electrical components within the system hard as well. So everything will be running at its optimum speed to deliver the optimum product. So you want to hit your optimum curve with your cooling and your power as well.
That's a great way to put it. That is so simple to think about in terms of reaching that optimum curve. I like that too much. But that drives exactly in, David, to what are the challenges with the next gen chip? You were saying we're going to 1 kilowatt a chip in a year to 2 years. That's amazing. Daniel, I've got to turn it back to you. We've seen the challenges that are occurring with rack densities and power demands, but could you talk a little bit about the chip challenges too? CPU, GPU, David and Hussam even mentioned some of them, and what does it really mean, Daniel?
Well, it means that when you get to those levels of chip density and heat flux and TDP, you're really in a situation where you need to start designing chips specifically for liquid cooling. So I believe that in the very near future, we'll see chip designs that allow fluid to run through the chip, inside the chip, encapsulate the chip with fluid, which is really the only way that we're going to be able to reach and meet these heat fluxes and TDPs that we need to cool with the technology. I think David made a very good point, because we've talked a lot about density and this increasing demand from the chip design perspective, but I think the society is also demanding that we leverage technologies that are much more efficient. And in many other industries, it's a no-brainer. Liquid cooling is very common, and we've really dragged on here in the data center industry with air cooling way too far. It's actually reached a point where it's limiting our innovation capability, and so many things are going to be enabled by liquid cooling. Anybody who's building air-cooled data centers today is definitely not building a future-proof facility. So that's something to definitely consider.
That's the key phrase, future-proofing. We're going to get back to that next, which really is taking a look at how the rise of cognitive computing will impact the mechanical design and operation and that future-proofing. But I want to take this back to you, Hussam. Are you seeing this at Microsoft? And you guys really know this well. You know, what are the challenges with next-gen chips, because you're so innovative there?
Yeah, I think there are a couple of challenges. For example, having high band memory on the chip, integrated memory on chip, that's a challenging thermal problem. It has a thermal resistance impact. We are seeing, as it's public, the AI chips are going well above some of the numbers mentioned. It's higher flux, it's more difficult to deal with. And on top of that, you could enable that with either using your your cold plates or your immersion, but then, you want to prepare your facility for that kind of a solution.
So we're going to take this over to you, David, now, too. It's a chip problem, and boy, did you just open things up by saying we may be moving towards 1 kilowatt. But let's talk about this for a moment. Chip challenges. You see it at Sandia all the time.
Right. Yeah. So as we're looking down the road, I mean, we're putting racks on the floor right now that have a density of around 35 or 40 kilowatts per rack. And our next system is already slated to be right around 75 kilowatts a rack. So definitely need to be liquid cooling. And the chips are being tasked, and our utilization, that's what's a big thing. The utilization rate for our systems, which is crazy, is right around 97% utilization, and that's year round. So basically, we don't really have time to a breather to let things cool down. We need to be spot on with what we're doing with our cooling, but I'm all into liquid cooling. So basically, we're into warm water cooling, and I think that what we need to do, our next step, is look toward immersion to get 100% of the electronics cooled and dissipate the heat and reutilize the heat, waste heat for low-grade work around here at Sandia.
Gotcha. Fantastic. So let's move on to that big question that you just brought up, Dave, and that is, how can you, and you didn't put it this way, but we're seeing pushing IT utilization up, and consequently, it's a re-architecture of the data center, Daniel. And we have to adequately manage rack density and heat, but at the same time, we've really got to ask, has cognitive computing impacted the mechanical design? Are we really talking about how do you future-proof that thing right at the bottom where it says future demand? Daniel, what are you hearing from your customers? What are they doing? What is Submer doing to help them? And how do you need to re-architecture a system, a data center?
Yeah, so there's a big worry that the form factor of immersion in a traditional data center is disruptive. That's obviously one of the customer's biggest concerns. I mean, I've built these things vertically for ages, and now you're telling me that they're going to go horizontally in tanks. And I built my data centers with 30 feet high and things like that to be able to manage airflows and plenums. And so the whole concept, there's obviously those brownfield retrofit-ins in existing data center, and there's some very interesting implementations that we've been leveraging in existing shells, where essentially we've removed raised floors and ceiling plenums, and we've built mezzanine, and we have 2 heights of immersion tanks, which really brings then the challenge of how do I actually deliver that amount of power in that space. Immersion tanks today, they're available in 100 and 200 kilowatt configurations. That's not going to be the challenge, because there's still a lot of room for improvement when it comes to the immersion platform itself, the immersion fluids, the system design, the chip design, as I was referring to as well. So there's tons of work to be done there. We're just at the very start of that journey. I wouldn't kind of get too fixated on the current immersion tank capabilities that are out there. Then when it comes to future-proofness, we believe that a future-proof facility is going to be a facility that's not only dense and efficient from an electrical utilization perspective, but that is also transitioning from being a burden for the society to a benefit. And that's going to be through sustainability. That's going to be through that capability that Dave was referring to of capturing 100% of the energy in very warm water or very warm fluid and being able to leverage that energy elsewhere or in the vicinity of the data center, be it, as mentioned, in district heating systems, neighboring industrial parks, neighboring commercial facilities, etc. And that connects to future-proofness, we believe is going to also be very connected to site selection, where you can monetize that energy, where you can monetize that energy reuse, that heat reuse. It's going to open a whole new business model for data centers, and I believe it's going to be the main reason for site selection in the not too distant future.
I've got to say, Daniel, thank you very much. I apologize. That was my own problem with mute. But the problem being that you talked about burden and benefit. There's a huge cost savings here, Daniel. Can you just talk for a moment about what your customers are seeing in savings of space, savings of equipment?
Yeah, so savings of space with immersion, you're typically, because you're removing crack units and CRAHs and air handling and a whole lot of infrastructure that's not needed anymore, obviously chillers and compressors, you're typically freeing up between 70 and even up to 80% of data center floor space, both inside and outside of the data center. So the footprint's substantially smaller. We've seen scenarios where a data hall has 4 megawatts of power availability for a traditional air-cooled environment, and we tend to stick just 40 tanks in a little corner, and then the rest of the data hall is just completely empty because it was originally designed for air. So from a space-saving perspective, the leap is substantial. When it comes to a CapEx investment for immersion technologies, typically we see the pure CapEx investment to be pretty equivalent in the same range for, let's say, highly efficient air free cooling technologies. So what typically hyperscalers would be deploying. But then when it comes to the operational costs, we see a humongous reduction delivered by immersion through obviously the energy savings, the removal of all those fans that were in the systems are not there anymore, the zero water consumption that the technology also brings to the table, which is also a novelty, and being able to capture that 100% of the heat that's generated in an immersion tank and taking it outside or getting it transferred to a secondary loop. So those are some of the benefits. OPEX-wise, typical savings are in the range of 40% for single-phase immersion technology.
Fantastic numbers. Thank you. Hussam, I've got to turn this over to you. When we talk about doing immersion, boy, oh boy, Microsoft knows what it's doing. You even go down to the deep ocean. So talk about this a little bit. Have you seen any changes in the architecture, the cost in the space, and especially how are you at Microsoft actually doing this future-proofing?
Sure, yeah. I mean, we have made announcement of one of our immersion deployment at Quincy in Washington. You know, one of the, obviously, you're bringing tanks now instead of racks. You get this box full of fluid, and you want to deal with it, and now one of the main aspects is your server service model is now different. Originally, you had a stand-up vertical rack and you pull server out. Now you got server dunked in, you want to pull them out, and there's a bending radius. So there were a lot of learnings on how that could be done and done in an appropriate way. One thing I wanted to highlight is, for example, you have OCP immersion workstream groups, and they are looking at and publishing specs on how you service the immersion tank and what could be a more unified form factor to make it easier on the server manufacturer and suppliers to actually have their servers be form factor friendly with tanks and all that stuff. Another important thing to take into account is the compatibility. That's a big deal. The material compatibility of the hardware with different fluids they're subjected to. So there is a plethora of things need to be done for readiness. And again, this is because the technology is at a relatively earlier stages, but I think the more we streamline it through OCP and other venues, the wider the adoption will be.
So let's get back to this question that you brought up, Hussam. Form factor, always an important part of life. As we start moving towards more of the immersion cooling, and with big folks like yourself behind it, are you seeing that there is a change in form factor? Are you seeing that there is a change in how the architecture can be redone?
Yeah, I mean, I think we moved from air cooling server to an immersion server. First of all, I don't need my fans anymore. I don't need the larger heat sinks anymore, and I could move to a very small, heatsink form factor. Another important element is potentially the thermal shadowing is not a challenge to me anymore. I could go to from a full width server to half width server. So you see all these specs right now that are public that shows servers with smaller form factor, basically because you can package and pack tighter, and that's the density proposition that the immersion allows you to.
Perfect point. Perfect point. Thank you for throwing in those fans there, because that's critical. What a waste of power and more airflow needed. David, got to turn it to you. You have been through this, and you can see the cost and space achievements. You've seen re-architectures, and you're really looking at future demand. Talk us through this. What have you learned? What are you doing?
Yeah, so I've seen the evolution of all that, the airflow, and the combination of the airflow and liquid cooling, and what we're doing now here at Sandia is basically we just built our first LEED Gold HPC data center that's 85% liquid cooled and 15% air cooled with air side economization. So basically we're moving away almost 100% from mechanical cooling about this time next year. We're going high warm water liquid cooling. So we're moving right into the next step, which would be immersion cooling. So basically what we would like to do is 100% liquid cooling at a high water input, so we can move 100% away from liquid cooling and go to our what we call a thermal siphon, which uses zero water evaporation to dissipate the heat into the atmosphere. It's basically like a dry cooler, only on steroids. And that's working really well. We're up to about 7 million gallons of water saved this year already just from doing a thermal siphon. So we're getting ready for. I don't have a huge amount of experience with the immersion. I have some that I worked up in NREL with the guys up there in NREL, but we're getting ready to talk about deploying our first system. Some of our HPC folks are a little bit worried about it, and I think that will be our biggest challenge. Because we've already prepared our data center. Basically, the way we design our data centers is for 5 to 10 years out. So we run the bigger pipes, put a lot of valves, pumps on drives, et cetera, et cetera. So we're ready for more liquid cooling and using less fan energy.
Got to ask, David, 7 million gallons saved.
Yes,
that
sir.
Is staggering.
Yes, especially here in the high desert, where water is like liquid gold. Yeah, it's an amazing system. We partnered with Johnson Control and NREL and placed the first one up at NREL, tested it, and now we have 4 up on our data center here, our legal data center.
Fantastic. Now, I've also got to ask, David, with this new HPC facility, which is 80 to 85% liquid cooling and the other is air, have you seen the ability for cost savings, space savings, architecture savings? Could you talk a little bit about that? Have you been able to cram more equipment in to make people like me happy?
Oh, absolutely. So the data center proper was designed with big spans on the beams across, so there's no beams going up through the floor, so it's all open compute space. It's the cost savings from fan energy versus pump energy isn't even comparable. The warm water cooling entering water temperatures at 75 F is huge savings. Allows us to get ready to get our deltas up higher so we could do some heat some of the buildings closer to us. So if you just do the math, if we were to air cool it versus liquid cool, we'd be in the millions of dollars of saving operational per year once we're fully operational.
Fantastic. Does this also allow you, by moving towards immersion cooling, does it allow you to have more flexibility? And it's something that's important to you, I know, of being able to expand to having more dense chips or being able to change out what you're doing. So is there flexibility inherent with this type of design, or is there not?
Oh, no, absolutely. I mean, to the point made earlier, the vertical versus horizontal computing, but the absolute space it takes up is approximately the same. And the weight on the raised floor is not a point loading. It's basically the whole system's across the floor, so you don't have to worry about the rolling weights or the point loading of the vertical computers. And so it bodes well for the future for Sandia and for anybody that has started in liquid cooling, because you're ready to roll into that next step, and the savings it's astronomical. You'll see it if you just did a month by month, and if you did some calculations on what you would save, and then actually see what you're saving. I was pleasantly surprised. I underestimated how much our OPEX has been saved.
That's fantastic. Give yourself a bonus. All right.
Well,
yeah, sorry.
I'll buy myself a beer.
Yeah, okay. I got to jump over to this. I know this is near and dear to all 3 of you, but we really got to talk about how does overclocking impact design. But this isn't just overclocking. It's also the concept of underclocking or downclocking. What does this really mean? Daniel, can you help people understand this? We all get it, but to a lot of people, they don't understand what's actually occurring and what the impact is, and how does immersion cooling save us from this major problem?
Yeah, so the reality in the majority of the data centers is that a substantial amount of the nodes that are in production are actually throttling back in the peak hours of the day, when the rack temperatures, let's say the in-rack temperatures, are at a challenging temperature, nominal temperature for the system. So there's there's tons of data and reports out there, but it's a nasty challenge for cloud operators, obviously like Microsoft and many others, that thermal challenges in the data halls actually imply not just that, they actually imply a big throttle back in the compute capability of that facility. Immersion just removes that challenge completely from day one. So if you just take those same nodes and dunk them into immersion tanks, you won't have that challenge. You won't have those hot spots. And so the compute will at least be running at its 100% nominal design. But then that opens the door to actually going a step further and overclocking some of the compute capacity that's in the data center. And that's something that we've seen quite a bit in the GPU space in the past in HPC. For CPUs, it's maybe not so common. And immersion now has an incredible playground, I would say, where we're super active as well in the crypto space. So crypto miners have realized that immersion is not only a way to cram more miners into the same space, into less space actually, but that they can actually overclock those miners by 30 or 40%, which obviously impacts directly into their company benefits. So kind of taking some of the learnings that are occurring in that space and how we could bring it into the data center wide space, I think is super interesting. And I know Hussam and his team have been doing quite a lot of work in that space as well.
That was the perfect segue to you, Hussam, and you are doing a lot of work in this space. Get to it.
Sure, yeah. The link you referred to, Stephen, shows a recent paper that we published at the ISCA, the International Symposium on Computer Architecture. And the title of that paper was Cost-Efficient Overclocking in Immersion-Cooled Data Centers. And in that study, it's public now, in the paper, we looked at the overclocking in immersion, whether it's small tanks, large tanks, and we also looked at chips ranging from workstation gaming to server class. And generally, when overclocking, there is this balance between power, performance, reliability, and lifetime. And the nice thing about immersion is it enables you to have better control over these knobs. And I can touch on a couple of them. For example, when we're talking power, or from a power perspective, your overclocking increases the power consumption substantially. However, your immersion cooling provides power savings that are either from that fan removal or that reduced leakage current at the chips, which partially, in total, offsets the higher power consumption when we overclocked. In a similar manner, when we look at lifetime perspective, immersion cooling can compensate for the lifetime degradation due to overclocking. Basically, we have increased thermal budget. We can bring the chip back to the required lifetime, even whilst we're overclocking, and we control that knob that way. You see, like, we get a lot of better control over these overclocking knobs when we apply immersion.
Fantastic. I'm going to remind everybody listening to this to make sure that they download those white papers. They are great. Hussam, I also want to ask, with the consortium that came together, is AI and ML, those densities that people are seeing, are they real? Are we seeing a lot of people? We know people are overclocking. It's normal. I come from the industrial world, and we did it 30 years ago, just in manufacturing. But I got to ask, are more data centers seeing AI and ML? Is this something that's coming that you've got to realize it's coming at you fast and it's going to impact you?
They are very real. The demand on AI and ML style workloads and deep neural networks, CNNs, and all sort of machine learning applications are only increasing, really. You can only, for example, look at some of the announcements by NVIDIA to see where we're at with the newest GPU cards and higher power. So it's a real thing, and it's happening, and it's one of the growing workloads that customers want to run. And again, it brings us back. Those chips, those AI chips, are typically much higher power than your typical compute as well. And you need to solve their heat challenge at the chip. They also, an ML or an AI rack configuration, you like to have proximity between the GPUs, for example. So you're able to run your workloads, GPUs and CPUs can talk to each other faster with low latency. That's where you need density. So this is how immersion ties into all of this.
Perfect. Absolutely perfect. Great segue for you too, David, because I've got to ask, when we're taking a look at this overclocking, are you doing it? Are you actually doing it at Sandia? And are you seeing that AI and ML is increasing the impact, just as you've heard from Hussam? Is this what you're dealing with on a daily basis?
Yeah, so basically, our clock speeds are right at 100%, almost 100% of the time. So if the workloads get heavier, they would change BIOS and then maybe do some overclocking. But right now, the impact right now is running at almost 100%, and keep them at 100%. Now I know definitely before we went to liquid cooling, we were seeing failures around down to 85%, 80% clock speed, and because of thermal degradation. So now, once we went to more direct liquid cooling, we're close to 100% utilization running all the time. And so, what I like to work on, and with the machine learning and the AI, is basically having everything work at the optimum curve. So my power queuing jobs, getting the scheduler to queue jobs at the optimum curve where power is available, where network connectivity is available, and where the cooling is the most optimum. And that's what, so that will help on the back end after you trying to dissipate the heat and looking at the energy that you're consuming when you're doing this overclocking.
Fantastic, thank you. Really good. So let's actually jump right into it then. Are we liquid ready? I love this picture because basically you better not be throwing your ice cubes on those chips. But I've got to ask, I mean, this is a talk about directions and trends, design changes. What design changes are occurring? That's the point of this conversation. Hey, we've got to move towards liquid because it is the right way to go when we're talking about AI, when we're talking about cognitive computing, when we're talking about ML. But the point is that really here, what type of design is needed? I mean, I've heard so many different things. I'm not too sure here. Daniel, can we start with you on this one? Because I want you to take it from your customer base, the folks that you're dealing with and helping every day.
Yeah, so are we liquid ready? I would say, so we are. The technology is people shouldn't be afraid to get their hands wet, literally. The technology is ready and it's mature enough to deploy production workloads. We have hundreds of tanks out there in, I'd say, many different applications. Running production critical workloads. The adoption is accelerating, and it's one of the biggest challenges that we've had up until now is the server manufacturers providing enough options and supporting immersion SKUs. So there's been a humongous leap, I would say, in the last couple of years from where we were and where we are today, and the willingness of server OEMs to embrace immersion projects. I think that was really one of the biggest challenges that we had. What we see today is that there's not a single workload or system design that can't be leveraged in immersion, and the technology is ready to be deployed at scale. The designing immersion into a greenfield data center is a no-brainer. It's much simpler than designing a traditional cooling infrastructure, and the supply chain is in place for immersion to be delivered through the traditional channels, let's say. So you wouldn't need to go to special vendors to source the immersion technology today, at least ours you can supply from those sources. What I believe we'll see is an acceleration in the next few months and year on the availability of systems that are in the market for immersion. We'll start to see some of the first, actually there already are some of the first immersion-born designs, which are just going to be much more optimal from a form factor, from a chip layout perspective, to leverage immersion technology, and that's going to get us to another exciting leap in water loop temperature. So we expect to see immersion systems delivering 150 and 160 F return temperatures in a year from now. And that's just based on having optimal server designs for immersion, which it's just a game changer for the industry from a secondary cooling infrastructure perspective, and how we can reuse that energy reuse that we were talking about. So yes, we're absolutely are liquid ready, or we have all the technology and know-how to be liquid ready available to us.
Great, thank you. Hussam, I've got to turn this one over to you because this really is a design challenge. And what kind of design are we working towards? If we're going to have both or we're only going to have one, how do we even do this? And again, I've got to ask you a very simple question. Microsoft, you're already at the edge. You are the edge. How do you deal with this edge issue of are we liquid ready or not? Got to ask you, sir.
Sure. I mean, you raise a bunch of important points. And, if we look at the journey of the air-cooled data center, and we have to take a couple things in mind. Number one is, in the light of the fact that as we are doing the different workloads, not all applications might require those higher flux chips, and we might end up with a mixed low flux, high flux chips environment. And also we need to be able to make a sensible TCO driven decisions. So do we need water throughout the data center, locally, where needed? And one way to also look at things is if you look at the journey of the air-cooled data center, I mean, there's been a lot of work and investment into optimizing air-cooled data centers. We started from chiller-cooled data centers with higher mechanical overhead, going into economizer hours and trim chilling, all the way to direct evaporative cooling. And those are air-cooled data centers. Now we want to bring in liquid cooling into them. You need the plumbing and the piping. And there are a couple of ways of doing it. I mean, one way is you basically build dedicated liquid-cooled data centers. They have the plumbing, they have dry coolers. That's one way to do it. Another way to do it is if you want to do things locally, you have your dry coolers and piping in a certain cell or location of your data center. A third way of doing this is using the liquid to air assisted options, which is something we've been presenting at OCP, which is again basically using liquid to air heat exchangers located in your data center that feed your tank or feed your liquid-cooled coplate setup. So there are multiple ways of doing it. If we go through, all the way to the edge, there is a nice benefit here that comes with immersion. Is my mechanical overhead is very simple. So yeah, it's a dry cooler, for example, and the footprint of my IT is small. So that makes edge location much more accessible. And then finally you look into, well, can I actually go a step further, and rather than just using my dry cooler to enable a chiller, an immersion deployment, can I tie into the district heating and actually benefit from that hot water coming out from the immersion tanks?
Absolutely perfect. David, I got to turn this over to you, but I'm going to say you should keep your ice cubes for your adult beverages.
Okay, yeah, right. Yeah, so basically, just to get a little nuts and bolts here, so if you have the typical raised floor system and you're starting to move toward liquid cooling, perhaps the first baby step would be maybe some cooling doors. So you get people used to the fact that the liquid's a lot closer to the door, and then if you arrange your racks in a laminar flow situation, so the back of the rack where the cooling door is would be the air to the next rack, and so forth and so forth. So that will slowly eliminate all the crack units or whatever the air you need to sustain that. So you get more and more closer to a liquid cooling, and people are getting more familiar with it and getting used to it, and you're getting the plumbing out there on the floor. And then also those crack units usually have 2.5 or 4 inch pipes to them. So basically that's pretty close to a CDU that can dissipate X amount of energy. So you could actually use existing infrastructure, looking at where it's piped, and place those CDUs in strategic places, and then distribute the water, whether under the floor or via overhead. So that's a good start. If you're in the old raised floor, you just don't have to run out and buy a new data center. You could basically do incremental changes that are very cost effective and will help you move toward liquid cooling.
Absolutely fantastic. Gents, I got to say that I apologize, but we are right at the end and running out of time. What I wanted to do was last thoughts, your final perspectives, concluding takeaways, whatever you want to call it. Daniel, I'm going to ask you as the sponsor to be right at the end of this. Why don't we start with you? Hussam, what are your initial takeaways for everybody who's listening into this great panel?
I think sustainability is key in all the decisions that we want to make. How do we use liquid cooling to reduce GHGs, to reduce energy consumption, to reduce water consumption? I think immersion really enables us to get there. So sustainability needs to be a key driver when adopting liquid cooling.
Fantastic. Thank you. David, to you, please, sir.
Yes. So basically, my word, it's not that hard. It's coming. People need to be ready for it. Don't be afraid. It's a cultural change, but it's a much needed change.
Great. And to you, Daniel, thank you so much for sponsoring this. Thank you for bringing, what a great group together. Just wonderful. And I've got to ask you, sir, what are we looking at here? Here's an example of a customer, but what are your key takeaways for everybody listening in now?
Yeah, so we're looking at a 1.2 megawatt data hall in the space of where you would usually just have probably 100 or 150 kilowatts. This is what an immersion data hall looks like typically. So a very clean space with just a very few number of tanks to hit more than a megawatt in the space. People are doing it. It's happening, and they're talking very well about the technology and about its capabilities. So I'm hoping that through that education, we'll accelerate the adoption. And once very few of us preaching alone in the desert, and now more and more are joining this liquid cooling dance. And we're definitely all here to support, and I really want to appreciate my colleagues and panelists here in this session, and thank you very much, Steve, for driving it for us.
Not at all. Hussam, David, and Daniel, thank you, all of you.
Thank you.
So I've got to say, folks, please remember, we have a roundtable on this exact same topic coming up right at the end of the top of this hour. So you can hit that link right next to you. You can see that roundtable link. But please give this session an overall rating for the quality of the content delivery experience. Let us know what your thoughts are. We need your input. And of course, click submit so that way we know what you're thinking. This information is incredibly important to us more and more. We are going to have back to that special cooling IT. So let's get onwards to the next one, which is join the roundtable right at the top. So that conversation is, are your data center workloads liquid ready? Please join us via the widget on the right. You can see it. It opens a new Zoom window. And of course, right at the top of the hour, we've got a presentation from Zinc 5, Steve Jennings, the Senior VP. That's taking a look at enhancing the future of energy storage, a solid case to embrace the next generation of battery technology. So with that, we're moving on to the next conversation and opening up the roundtable starting at the top of the hour. So please join us, challenge the ideas, share your insight, and discuss what's possible. We look forward to seeing you at the roundtable and, of course, at the next upcoming Zinc 5 session.